Welcome back to our channel today. In our lesson today, we are looking at equations involving fractions. All these are linear equations involving fractions. So we want to look at different conditions. If you observe, you could tell that the equations are different from each other, all right? So we want to consider different patterns that you expect algebraic equations, so long as it is linear. So for this first one, we have 7 minus a over 4 to be equal to 5. We have a single fraction equal to a whole number. This whole number has an invisible denominator 1, okay? So all you need to do is to cross and multiply. 4 multiplies 5 and 1 multiplies here. Therefore, 1 times here remains the same. 4 times 5 is 20. Then collect like terms. 20 will have to come over so that a will go to the right hand side so that a becomes positive. So I'll have 7 minus 20 equals, take a to the right hand side, and when it crosses, it becomes positive. When 20 crosses over here, it becomes negative. So 7 minus 20 gives us minus 13 equal to a. So our a is minus 13. All right, very simple. Now, this second one is exactly the same process, just that the whole number is by this side. So put 1 here, cross and multiply, then you simplify. So 2 will multiply 4, and then 1 multiplies here. So what do we have? 2 times 4 will give us 8. Then 1 times a plus 5 is same as a plus 5. Then collecting like terms, numbers will come together and then alphabet remains that position. So I'll have 8 minus 5 equals a. 5 is positive here. When it comes over, it is negative. So 8 minus 5 will give me 3. So our a is what? 3. You see that we followed almost the same process. Now looking at this one, we have binomials at the two sides of the equation. I mean the numerator. So what we do is exactly the same process. We cross multiply. So this process happens all when you have two fractions, one at the right and one at the left. Whenever you have two fractions like this, one at the right, one at the left, you cross and multiply. Now let me show you a different situation of this number 3. Sometimes you have, let's say 2x minus 2 over 3 plus 4x minus 2 over 2. And this equals 0. Now, you observe we have two fractions as well, just like we have here, binomials. So what I will do to this is to take 1 to the right-hand side. I would have 2x minus 2 over 3 equals, take this one across. It becomes negative 4x minus 2 all over 2. You know, when a positive crosses a equality sign, it becomes negative. So you discover now that we have the same situation as we have here. This equal to this equal to this. So when you have such cases, what do? You cross and multiply. So I'm going to cross and multiply. 2 will multiply here. So I'll have 2x minus 2 multiplied by 2, this denominator. Then 3 multiplies here. That is 3 will multiply. Because of this negative, it becomes a negative 3. Multiplying 4x minus 2. You fold the bracket. 2 times 2x is 4x. 2 times negative 2 is negative 4. The negative 3 times negative 4x, positive 4x, that will give us negative 12x. Then negative 3 times negative 2 is positive 6. All right? Then we collect like terms. 12 will have to come over to meet 4x, so that we have 4x plus 12x. 12 is negative, it has to be positive this side. Then 4 goes over, so we have 6 plus 4. Here gives us 16x. And here you have 10. Then we have to divide both sides by 16 to get our x. So 16 will take away x. 16 takes away 16. Or here, 2 can divide, we have 5. 2 divide, we have 8. So we have 5 over 8. And that becomes the solution. So when you have two fractions at the left hand side, or both of them at the right hand side. Take one to the other side so that you have something similar to this. Now let's come back and solve this. Or I'm going to leave you with this one. Solve it. Drop your answer in the comment section, since you are going to follow the same procedure. This is the same as this. Now let me come to this one. Looking at this number 4, you discover that it is different from here, here, and here. I have 3 fractions, 1, 2, and 3. So when you have such case, how do we simplify? I'll take you through the process. All right, so what you need to do is to find your LCM. The LCM of denominators. That is, what number, the smallest number, can 3 divide, and 7 will also divide it. That should be 21. 3 can divide 21, 3 can divide 21, 7 can divide 21. Now, when you have gotten the LCM, use that LCM and multiply each of the terms of this fraction. So I have 21 times 3x over 7 equals, same as here, 21 times 2x over 3, same as here, 21 times 1 over 3. Then divide. 7 can divide 21 to give me 3, right? Now 3 times 3x is 9x. Over here, 3 divided 21 is 7. Then 7 times 2x should give me 14x. And lastly, 3 divided 21 is 7. 7 times 1, I have 7. Now we have a non-fractional equation. So whenever you have 3 times fraction, all you need to do is to simplify it into a non-fractional equation. Now let's simplify. I'll take 7 to the left-hand side and take 9x to the right-hand side, so that 14 and 9x will come together. So if I bring 7 over, I'll have a positive 7. For 14, I'll have 14x minus 9x. 9 will come over this way to become negative 9x. So we have 7 equals 14x minus 9x should give us 5x. Use coefficient of x and divide. So our x will be 1 whole number 2 over 5. That is changing 7 over 5 into a mixed fraction. So for the fifth one, I have 11 minus 3x over 2 equals 2x over 3. Here is a binomial and here is just a single term. Now, when you have such case, what did I tell you about here? You cross and multiply. Okay? 2 multiplies here to give me 4x. That is 2 times 2x. Then 3 will multiply here. That is 3 multiplying 11 minus 3x. This guy is multiplying here. Now we have 4x equals, open the bracket. 3 times 11 should give us 33. Then 3 times minus 3x is minus 9x. Let's collect the like terms. This guy comes over here. I have 4x plus 9x equals 33. All right. So the next thing we do is to add 4x plus 9x is 13x equals 33. Then divide both sides by 13 so that we can eliminate 13 from here. Now 13 divided 33 should give us 2 whole number 7 over 13. That is changing this into a mixed fraction. So lastly, we have this situation. Let's also see how we simplify it. So we have 2x plus 2 over 4 to be equal to 1 over 4 plus 3x over 5. When you have 3 terms of fractions, what do you do? Remember how we solved this one. We will find the LCM of the denominators, 4, 4, and 5. What number can 5 and 4 divide with no remainder? The smallest number. That should be 20. There are many numbers that 4 and 5 can divide, even 40, even 60. But then we are looking at the smallest number that 4 and 5 can divide. So since that is 20, use 20 and multiply all the fractions. So I would say 20 times 2x plus 2 over 4 equals 20 times 1 over 4 plus here 20 times 3x over 5. Now 4 will divide 20, I'll have 5. 5 multiplies here. So 5 times 2x is 10x. 5 times 2 is 10 equals 20. 4 divided 20 is 5. 5 times 1, I have 5 plus 5 divided 20 is 4. 4 times 3x will give me 12x. The next thing we do is to collect the like terms, right? So 10x will come and meet this guy. 5 will come and meet this one. So we have 10 minus 5 equals 12 minus 10x. This is 12x minus 10x. 5 minus 10 minus 5 is 5. 12x minus 10x should give me 2x. Coefficient of x will divide. So I will have x to be equal to 2 divided 5 is 2 whole number 1 over 2, changing to mixed fraction. So this is how we solve different conditions of algebraic fractions. I would also like to introduce you to this condition. Look at this. I have a mixed fraction. Don't get confused. We are solving exactly what we have done here. All you need to do is to change this guy into improper fraction. So 2 times 3 is 6 plus 1, 7. We have 7 over 2 plus 3x over 4 equals 7x over 4. Now you can simplify this as your assignment and drop your answer in the comment section. I will see it. Thank you so much for watching. Please do well to like this video, share it to your friends, and subscribe to my YouTube channel for more interesting mathematics tutorials. See you in my next video. Bye.